Welcome to another episode of Matthewton. If you have not watched episode 305, you can click on the link above. This is episode 306. Trigonometry extended to any angles. You may need to recall episode 304, quadrant and base angle, and episode 305, redefining trigonometry. Let's get back to our unit circle centered at the origin and some random angle theta in standard position. It doesn't necessarily have to be in the first quadrant. Well, that's much better. Working with the generalized definition of sine and cosine from episode 305, the point of intersection of the terminal ray and the unit circle, say P, is cosine theta, sine theta. Let's, just for the sake of beginning with, take theta to be 135 degrees. The base angle is 45 degrees. The perpendicular from P to the x-axis meets the x-axis at, say, M. Triangle PMO has been magnified to the right for the sake of convenience. In triangle PMO, cosine 45 degrees is MO by PO and sine 45 degrees is PM by PO. Since PO is the radius of the unit circle, PO equals 1 unit. Therefore, MO equals cosine 45 degrees and PM equals sine 45 degrees. Furthermore, since we know the values of cosine and sine 45 degrees, MO equals 1 by square root of 2 units and PM also equals 1 by square root of 2 units. If n is a point on the y-axis such that Pn is perpendicular to the y-axis, we can deduce that n is 1 by square root of 2 units from O. Hence, the coordinates of n are 0, 1 by square root of 2. Notice that m is minus 1 by square root of 2 units from O, or the coordinates of m are minus 1 by square root of 2, 0. This implies that cosine 135 degrees, the x-coordinate of P, the same as the x-coordinate of M, is minus 1 by square root of 2, and sine 135 degrees, the y-coordinate of P, the same as the y-coordinate of N, is 1 by square root of 2. It's now time for a do-it-yourself. Find the sine, cosine and tangent of the following angles. Pause the video if you would like to try it yourself. Here are the answers. Did you get all of them right? Notice that in the first quadrant, all the three trigonometric ratios are positive. In the second quadrant, only sine of the three ratios are positive. Tangent alone is positive of the three ratios in the third quadrant. As for the fourth quadrant, only cosine is positive of the three ratios. The mnemonic ASTC may be used to remember which ratio is positive in which quadrant. And in the event you cannot remember ASTC, you can always remember the phrase all students take coffee. The trigonometric ratio of an angle is dependent on the sine of the ratio contingent on the quadrant of the angle and the trigonometric ratio of the base angle. Let's use an illustration of sine 240 degrees. The base angle for 240 degrees is 60 degrees and 240 degrees lies in the third quadrant. Sine in the third quadrant is negative, and so sine 240 degrees equals minus into sine 60 degrees. Minus sine 60 degrees. That gives minus square root of 3 by 2. Now for a do-it-yourself. Evaluate the following trigonometric ratios. Pause the video if you would like to try it yourself. Did you get these as you work through? Or these as your final answers? Now for our open problem. Try solving for the values of a and b, where a and b are integers that satisfy the following equation. We'd love to hear your responses to this, so do leave us your comments. If you like the video, don't forget to hit like. If you think it's worth a share, do share. If you wish to stay updated about new videos, do subscribe. Oh, and don't forget to leave us a comment if you want to share your thoughts about the video.